Okay, so this lesson we're going to start with exercise 8b, translations. Now, from the last lesson, we talked about the translation is one of the isometric transformation that involving just to shift the object by a given distance in a given direction. So we'll start with the definition first. Translation basically it's like a shifting. All right, so imagine like for example, I'll have the word translation here. You actually shift the words, horizontally, vertically, or in a diagonal directions here, and that's what the translation is about. Okay, so translation is an isometric. Now I hope you still remember what's the meaning of isometric transformation. Isometric transformation means the size is not going to change. Okay, so it is going to be a congruent shape, which means that the size and the area, everything is the same. It's going to remain the same for the objects there. Okay, and translation is one of the, well, I would say the easiest type of transformation. All right, because you're just shifting a diagram or a figure by a given distance in a given direction. Alright, so we'll have like two important information here. Firstly is the distance. So we need to know what sort of distance you transform, you'll translate this object. All right, and in which direction you translate this object. Okay. All right. So in this case here, we're going to use another sort of like terms to describe the direction and the distance. We use something called a vector. Can be used to describe the distance and direction of a translation. Okay, and this is actually quite important. A vector. Later, you're going to study, especially in physics and higher level mathematics. You're going to study about what is a vector. So a vector is something to do with magnitude and direction. So right now in year 8 level, all right, you just need to know there is a vector like A and B like this. All right, and this can be used to describe the distance and then also the direction of the transformation. All right, so what does that mean? What does that mean by describing a distance and also the direction of the translation? All right, so if we look at this vector here, we've got A and B. This A here representing the horizontal change in distance. Okay, so if it's positive, then you're moving to the right. If it's negative, then it's moving to the left. So basically, this A here representing the horizontal change of distance. All right, so therefore the B here is actually pretty easy. It's the vertical change of the distance. So if you think about a coordinate plane where you have the horizontal and the vertical axis, where it's like vertical change of the distance, or you can have the horizontal vertical xy axis, right? So A representing the change in the horizontal distance and B representing the change of the vertical distance. All right, and of course if A is positive, all right, so if A is positive, if A is positive, then it's moving to the right. Okay, if A is negative, then it's moving to the left. All right, if B is positive, then it's going upwards. All right, and then if B is negative, then it's moving downwards. Okay, all right. Or shifting up or shifting down. Okay, same idea. So let's just have a look at this first type of sort of like questions here. If I give you a vector which is like 4 and 3 here, so then this vector here is moving to the right or shift to the right by 4 units, and then shift down, all right, by 3 units. or actually wait, that's not shifting down by 3 units, it's actually shifting up. It's a positive, all right? So that's very important. Don't make a mistake like I did. All right, it's shifting up by 3 units. So this is how you actually, find out, what is the direction and also what is the magnitude. So the magnitude is basically the number here tells you what distance the object is shifting. And the direction means, obviously, if it's positive, then it's to the right. If it's negative, it's to the left, for the horizontal change of the distance. If it's vertical change of distance, and it's moving up and down. All right, so let's have a look at another one. If we have something like -1 and 4. Now, if it's -1 and 4, obviously it's a negative for the horizontal distance change. So it's shift to the left by 1 unit. All right, and then as you can see here, this is still positive. So it's a shifting up by 4 units. All right, now the type of question you're going to get in this exercise is actually pretty easy, to be honest. All right, so we're going to just try a few questions. Example 1. Now, the first type of question you might be able to see is you need to write down the vectors that take each point to its image, okay? Sometimes by drawing a diagram, it really helps you. So we'll just write this one down first, write the vectors. So you need to write down the vectors like in this format, okay? A and B format. That takes each point to its image. All right, so let's have a look at the first type of question here. So the first question is A, you've got a point 2 and 3. Now it's shifting to A dash, and the point is now 3 and 2. So what you need to do is write down what is the vector here changes. It's actually pretty easy. If you find it's really hard to understand, try to draw a diagram. Otherwise, it's actually really easy. Basically, what you're looking at is the difference between the x coordinate and the difference between the y coordinate. So between the x coordinate, as you can see here, from 2 to 3, obviously you add 1. So therefore, in the vector form, it's positive 1. Okay, the point is shifting to the right by 1 unit. All right, then you look at the y coordinates. It's from 3 to 2, so it's minusing it. Okay, so you minus 3 by 1, so it's shifting down by 1 unit. So therefore, this is -1, and that's how you actually did the questions here, and that's what a vector is. Okay, 1 and -1. It's about the gesture changing. Now, for those students who are the visual learners, okay, if you prefer to do the questions by having a diagram, yes, you can. So what you can do is by just labeling the points. All right, so 2 and 3. So for example, that is the first point here, which is A, and then you label your second point like an A dash, which is you've got a 3 and 2. All right, so this point, and you start to think about how does that point, all right, is changed, okay, from, point here A to A dash. All right, so how is that possible? It's changing. So basically what happens here is the point is actually moving to the right, okay, by 1 unit, then moving down by 1 unit. Obviously you can move down by 1 unit first and then to the right as well, so that also works. However, the way to write the vectors is we always write the first point is the horizontal and the second point is the vertical. All right, so we go horizontal first and then vertical down by 1 unit. They're both 1 unit, and that's how you get to the point. Okay, so if you prefer to use the visual diagram here to help you to write on the vectors, you can. I certainly just prefer to use the normal, like a number calculation. That really helps me to do the questions there. Okay, so for example, if I just give you another questions here, I've got point F, 1 and -3. Now it's moving to the point F dash, which is -2 and 2. All right, so when it comes to this question here, then what do we do, and how do we actually find out what is the vector that makes the change? So the same thing applies, right? So we just look at the x coordinate here from 1 to -2. Okay, from 1 to -2, obviously you minus a 3 to get -2. Okay, so that's -3 here, so it's moving or shifting to the left by 3 units. Okay, then you look at -3 here, from -3 to 2, of course you actually plus a 5 here to get from -3 to 2. So it's actually shifting up by 5 units. And that's the vectors you're supposed to write. Alright, so that's how you actually do the question. Alright, which is pretty much is, very straightforward. Okay, so this is the first type of question. Now the second type of question is where you need to actually draw a diagram. Okay, so I will write this one down. Example 2. Right, so the second type of question is where you have a diagram. They give you a diagram with a shape, a solid. It can be something like this, any random solids like this. All right, they do also give you the points. All right, so you will understand what the point is. And the question says you need to shift this or translate, this diagram by a given vector. Okay, so you're going to draw, for example, the image of the shape translated by the given vector. Okay, so for example, the first one, they give you a vector of 2 and 3. And for the second one, they give you a vector of 4 and -2. So when it comes to a question like this, all right, obviously the first step is if they give you the coordinates, all right, that would be great. If they give you the coordinates and you've got everything you need, and then you can obviously move the coordinate around. If they don't give you the coordinate, they give you the grid, which means they also give you the coordinates, and that also pretty much it. That's it. All right. So all you have to do is look at the coordinates. Okay. So I'm just label some coordinate for you. All right. It's not going to be accurate. Probably it's not. I don't think I actually did a really accurate scaling, but it serves the purpose. Okay. That's -3.5. How about that? Okay. All right. So we've got all the coordinates on kind of like need. Okay. So we've got A, B, C, D. And then let me just write down all the coordinates for you. All right, it's just easier for you to actually do the translation. So coordinate A is -2 and 3. Coordinate of B is -3 and 2.5. It should be 2.7 maybe, but let's just say 2.5. Coordinate C is -3.5 and 1.5. And the coordinate D is -1 and 2. So we've got everything we need. Now, once we have this coordinate here, then you just need to look at a translation factor here, applying this translation factor 2, 3, which means it's shifting to the right by 2 units, and then shifting up by 3 units. So all you have to do is simply plus these two coordinates by these two numbers there. All right, so therefore, A dash, it is going to be, all right, sorry, I'm just using this color here. A dash, all right, is just going to be, if you think about this, you've got -2, and that's a 2 here, so you plus them together, which is equal to 0, and 3 plus 3, which is that one there, 3 plus 3 is just equal to 6. So if you follow this idea, all right, just keep plussing the numbers, you should be able to get, another 4 points after you translate it. So if you just keep adding the points, point D is 1 and 5. Now, once you have the calculation for the points, all right, you can just label those points and plot those points on a diagram, and you've done the translation, correctly. All right, okay, all right. Obviously, the 0.6 is roughly here, so it's pretty much hard to draw. All right, so this is like an A dash, -1.5. Okay. Listen, I'm not going to do a very accurate diagram here just because I don't have the accurate, axis, all right, so therefore it's probably not going to be that accurate, all right, but as long as you actually understand what's going on and the process, that's the most important one, okay? 1 and 5, all right, so roughly like here, all right, so that's point D, and then you connect them together, okay? So obviously the diagram is not that accurate, then that just means you actually translate this one as shifting to that direction. Obviously, it does make sense. You're actually shifting 2 units to the right and then 3 units up. So the diagram will be roughly in this position here. So of course, if you draw your coordinate axis very accurately with all the information labeled properly, then you should be able to find a very good an accurate diagram. All right, now for the second translation, same thing applies. All right, we just need to find out the new coordinates, okay? So all you have to do is, again, you plus the numbers, all right? You plus the vertical, and you plus the horizontal coordinates respectively. All right, so that's 2 and 1. B dash is 1 and 0.5. C dash is 0.5 and -0.5, and D double dash is 3, and 0. Okay, so once you have done the calculation, then you actually can just put everything, plot the points, and you draw the diagram. That's what you can do. All right, in the exercise, they actually give you the diagram with the grid. Okay, so you have the grids labeled for you, so you know exactly where is the grid, and you can simply just count the grids. Okay, so like for example, shifting to the right by 2 units, that's just 1, 2, and then shifting up by 3 units, that's 1, 2, and 3, and you have a point here, and you can label that point D dash. Okay, so that's just much easier if they provide you the grid. Okay, all right. The next one that I would like to do is another type of question. Example 3. All right, so let's have a look at this type of question this time here. All right, so for example, if they give you a question like this, I'm just going to find a question from the textbook. Okay, so let's have a look at this question here. All right, so if they give you those vectors, right, so like 2, 3, okay, oh wait, just give me 1 second. It's question 9, so from the exercise. So it says a car makes its way around the city. Alright, straight grid. Okay, a vector 2 and 3 representing traveling, 200 meters east and 300 meters north. Okay, so just write it properly here. 2 and 3. That just represents traveling 200 meter east and 300 meter north. Okay, now it does make sense, right? If you think about the coordinates here, that's east, that's north. Oh, oops, that's east, that's north. All right, that 2 here representing like 2 units to the right, which is 200 meters in this case to the east, and then 3 is 300 meters to the north. All right, so now the question is actually pretty straightforward. The question asks you about find how far the car travels if it follows these vectors. So they provide you a series of vectors, which tells you a series of change of directions and also distance, and asks you how far the car has traveled. Okay, and that's the idea. All right, so what we do here is we think about the direction, and also we start with like a coordinate, and then we start to look at what is the journey and what does each vector do here. All right, you can draw a diagram to help you out. All right, so firstly we've got 2 and 3, right? So 1, 2, 3, 1 and 2, 2 and 3. So firstly the point is here. Okay, obviously the car is actually traveling 200 meters to the east, 300 meters to the north. All right, so then the first thing we'll do is we actually label this point here and just use a different color. Now the car is actually traveling 5. All right, -5 means 5 units or 500 meters to the left. Okay, so that's like a 100 meter, 200 meters, 3, 4, and 5. So that goes to the actual -3. All right, and then that's the point, and now it's traveling up by 100 meters, right? Traveling up by 1 unit. So now this point is the second point for the car, all right? And that's the second location. All right, so if we just call this point as A, now the point here is just going to be A dash. All right, so we've got A dash now. All right, so after this, the car is now traveling, if you think about this, 3 units or 300. Okay, so that's 1, 2, and 3 to the right, and then 300 down, 1, 2, and 3. Now the car is actually at this point now. All right, so let's just label this again. So now the card is actually at this point, all right, and that's a double dash. All right, finally, we look at the final position, and the final position is -2 and -4. All right, so -2 and -4. So starting from here, -2 means we're actually going to the left by 2 units. Okay, so that's 1, 2. Okay, and then going down by 4, that's 1, 2, 3, and 4. So that's -3 here. So that's now the final position of the car. 3 triple dash, all right, 8 triple dash on top. Okay, all right, and this is how far the car has traveled. All right, so now the question says like in how far the car travels if it follows these vectors. So then what we are really thinking about is if the car is actually initially at this point, that's A, which is this point here. All right, the final position of the card is here. We can actually look at how far the car has traveled, right? So the car has traveled, all right, so that's, from 2 to -2, that's -2 here. It's actually traveled 400, okay, meters to the left or to the west, okay, and then from this point, it's traveling down by 1, 2, 3, 4, 5, 6 units, okay, or 7 units down, okay. The easy calculation that you can do is just look at this point and comparing to that point. From 2 to -2, it's actually moving 400 meters to the left, and then from 3 to -4, it's moving 700 meters to to the south. All right, so that's how you do actually answer the question. It's actually pretty easy. So you don't really need to worry about these 2 points. And we're only looking at the starting position and also the finishing position for this question. Okay, all right, so that's all for this question, and that's it for this exercise. It shouldn't be very hard for you guys to work out the answers. If you do have any questions, please let me know. Thank you.